Hey guys, Wilker Patrick, nursing educator in Psych Corsetta. If you're struggling with arterial blood gas interpretation and compensation, we're about to make it super easy for you. Now we're going to get right into it. I don't want to waste any time. I want you guys to download the ABG worksheet that is for free on our website and the link below in our description. All right, so let's go over it. ABGs. So what are ABGs? It's arterial blood gases. Arterial blood gases are a way for us as nurses and of course other healthcare professionals to understand where our patients are at on their respiratory function. See, our bodies have an acid-base balance. A normal acid-base balance is 7.35 to 7.45. The acid-base balance is measured by something called the pH. So once again, that normal range, 7.35 to 7.45. Other normal ranges that you need to know to interpret an ABG is PaCO2, which is partial pressure of CO2. It is 35 to 45. So think of it no different than pH. It's 7.35 to 7.45. Well, CO2 is 35 to 45. Just drop the 7 point. And then we have something called HCO3. HCO3 is bicarbonate, but the normal range for HCO3 is 22 to 26. So you guys are going to need to know those normal ranges. If you guys have the ABG study guide, make sure you guys write that down. So now that we know our normal ranges, we need to know what it means when they're out of range. So a pH, let's start with that. So once again, pH is 7.35 to 7.45. If it's low, so below 7.35, it is acidic. If it's high, so above the 7.45, it's alkaline. We'll get into the steps of interpreting ABG, but this is the first step, is determining if it's acidic or alkaline. You guys need to know what it means when it's out of range. All right, so let's go over CO2. So we mentioned earlier that CO2 is acidic. So CO2 is owned by the lungs. The lungs are responsible to expel CO2. So if you guys remember a quick little respiratory anatomy session, is that the respiratory system inhales oxygen and exhales CO2. Well, CO2 is acidic. So if we have any issues with a CO2 buildup in our body, our lungs are going to compensate by increasing our respiration rate to get rid of that CO2. And the lungs are very fast acting on changing the pH balance. So of course with this range, if it's below 35, we have a low amount of CO2 in our body. If it's above 45, we have a high amount of CO2 in our body. Okay, moving on to HCO3. So once again, bicarb. Bicarb is controlled by the kidneys. The kidneys are the buffer of the pH system, but the kidneys are much slower on controlling the acid-base balance than what the lungs are, because the lungs can just increase the respiration rate and change it right from there. But the kidneys have to do a little bit more work to get rid of or hold on to more bicarb. So if the bicarb HCO3 is below 22, there's low bicarb. If it's above 26, it's high bicarb. CO2 is acidic, bicarb is alkaline. You guys need to know that. All right, guys, so let's get right into how to interpret the ABG. So once you guys understand those foundations of the ABG values, it's going to be much easier for you. Now, step number one is determining if it's acidic or alkaline. So what do we look at? The pH. The pH, the normal range, 7.35 to 7.45. Look at that first. Now let's determine if it's acidic or alkaline. Now, when determining ABG, we have four options, okay? So we have respiratory acidosis, metabolic acidosis, respiratory alkalosis, metabolic alkalosis. Those are your four options with ABGs. So after we determine if it's acidic or alkaline, now we need to understand if it's due to the respiratory system or if it's due to the metabolic system. So respiratory, of course, lungs. So what do the lungs control? CO2. CO2 is what? Acidic. And then we have metabolic, which is what? The kidneys. And what do the kidneys control? Bicarb. And what is bicarb? It's alkaline. Now you have two options on determining what method you want to use. There is the Tic Tac Toe method or the Rome method. Now I prefer the Rome method. I used the Tic Tac Toe method at first, but the Rome method helped me understand what would be the next step of determining what kind of compensation there is. But let's just go over both for you guys, and you guys can determine which one works best for you. Let's do a practice problem together so that way you guys can see it in action and it'll help best apply what we're learning right now. So we have a pH of 7.48, a CO2 of 32, and HCO3 of 24. Hey guys, it's Wilker Patrick, nursing educator in Psych Corsetta. I wanted to let you guys know that I will help you with anything you need at any time if you just send me a text at 940-218-4062, 940-218-4062. Let's get back to the video. Okay, so our first step is, number one, identify if it's acidic or alkaline. So what do we look at? The pH. So the pH is 7.48. That's above the 7.45. If it's high, what do we know? It is alkaline, okay? So now let's determine if it's respiratory or if it's metabolic. So we know it's alkalosis, but what is it caused by? Okay, so let's use the Tic Tac Toe method. If we orient the Tic Tac Toe board just like this, we are able to fill in the blanks and we'll find out if it's metabolic or respiratory. So we put right here that 7.48, it is alkaline. Okay, so we have our CO2. Our CO2 is 32. What's the normal range? It is 35 to 45, so the CO2 is low. Okay, so we put that over there. And then we move on to the bicarb, which is 24. The bicarb normal range is 22 to 26 once again, so we put that right here. So if you guys understand tic-tac-toe, you're going to understand this, is that there is 3 in a row, so we have respiratory alkalosis. Why do we know that it's respiratory? Is because respiratory controls what? It controls the CO2. So it's due to that high pH is due to the respiratory system because the CO2 is low. Now the tic-tac-toe really helps with visually understanding it. So that's an easy way to do it if you want to use the tic-tac-toe method. Now let's go over the row method. So the row method is just a little bit more difficult to explain, but it does help understand the compensation a little bit better, at least in my opinion. But we're going to get right into it. So ROME, what does it stand for? ROME stands for respiratory opposite, metabolic equal. So let's go to another practice problem here. We have a pH of 7.32, a CO2 of 48, an HCO3 of 27. So what does respiratory opposite and metabolic equal even mean? Well, what it means is respiratory, once again, CO2, because the respiratory system controls CO2, if that CO2 level is going the opposite direction of the pH, it means that it's due to the respiratory system. So once again here, if we look at this problem, let's immediately apply it. So we have a pH of 7.32, the CO2 is 48, the HCO3 is 27. Step number 1, let's determine if it's acidic or alkaline. So we have a pH of 7.32, it's below the normal range of 7.35, so it is acidosis. So what is it caused by? So if we use the ROME method, respiratory opposite, metabolic equal, let's look at the CO2 first. The pH is low. The CO2, what's the normal range of CO2? 35 to 45. The CO2 is high. The arrows are going the opposite way, so they are opposite. Okay, so the pH once again, low, CO2 high. So that means respiratory is opposite. Respiratory acidosis. Okay, so let's turn it around here. Let's say that the pH was 7.32, the CO2 was 41, and the HCO3 was 18. Okay, so let's do the ROME method again. pH 7.32. Step number 1, is it acidosis or is it alkalosis? Okay, we know that it's acidosis because it's below the 7.35. Okay, going on to CO2. It's 41. Okay, well that's normal for the CO2. 35 to 45, it's in normal range. Okay, so it's not respiratory opposite, so let's move on. Is it metabolic equal? Is the metabolic, aka bicarb, HCO3, going the same direction as the pH? Well, we see that the HCO3 is 18 here in this case, so it is low. The pH is also low. They are going the same direction. So metabolic equal, so this would be metabolic acidosis. Now, once again, guys, make sure you guys download our free ABG worksheet on our website to really test your knowledge and get a deeper understanding of how to use either one of these methods. Now, let's get right into compensation of an ABG interpretation. Now, this is step 3 of the ABG interpretation. We are asking the question if it is compensated. So our 3 options here are uncompensated, partially compensated, and fully compensated. So this is what you need to know about each one of these options. So uncompensated, the pH is at normal and nobody is helping. So whether it's respiratory or metabolic acidosis, for example, either the CO2 or the HCO3 is going to be in normal range, where it should be out of range to compensate the acid or the alkaline. Now the next 2 options are very easy because there's some simple rules that you can follow that will help you identify it immediately. So partially compensated. Partially compensated, the pH is abnormal, but so is everybody else. So if all 3 of your values, the pH, the CO2, and the HCO3, if all of those are out of range, then it is partially compensated. So remember, partially compensated, everything is abnormal. Okay, moving on to fully compensated. The way you can immediately identify this is if the pH is normal. It's the only one where the pH would actually be normal. It'll be close to being abnormal, but it is in the normal range. So you're going to see the pH between 7.35 and 7.45. Now, if you see a value that is like 7.36, it's close to being abnormal, or if it's right on the line, 7.35, then this would be an acidosis. Now, if it's on the other side of the spectrum, where it's close to being abnormal on the alkaline side, where it's exactly on 7.45, or if it's 7.44, that's where it would be alkalosis. So the big kicker here is that if it's fully compensated, your pH is going to be normal. But your other values, such as your CO2 and HCO3, of course, are not going to be normal. So let's do a quick practice question here. So we have a pH of 7.36, a CO2 of 48, and HCO3 of 28. So first step, let's determine if it's acidosis or alkalosis. Well, we see a pH of 7.36, it's in the normal range, but if we look at the other values, they're out of range, so this would be considered acidosis. CO2, let's determine now if it's respiratory or metabolic. Now you can use the Tic Tac Toe method or the row method. I'm going to use the row method in this quick example. Respiratory opposite, metabolic equal. So pH is low, considering it's on the brink of being low. And then we have a CO2, 35 to 45. It's 48. It's high. So respiratory opposite. This is respiratory acidosis. Now, step number 3. What is the compensation? Is it uncompensated, partially compensated, or fully compensated? Okay, remember, number 1 rule, we can identify it immediately because what is happening? The pH is in normal range. So this is respiratory acidosis, fully compensated. Once again, you guys can have more practice questions to test your knowledge on our free ABG worksheet that you can download from our website. Go to the description below. Next one, we have a pH of 7.31, a CO2 of 38, an HCO3 of 15. All right, step number 1, acidosis or alkalosis. We have a pH that is below the 7.35, so it is acidosis. Okay, step number 2, is it respiratory or metabolic? Using either method here, you can see if you go through the steps, it's metabolic acidosis. Okay, now look, let's ask ourselves step number 3, is it compensated? Okay, we look here, that is pH is 7.31. We know that it's metabolic acidosis. We have a low HCO3 that is causing this because it's metabolic acidosis once again. So our CO2 should be compensating, so our lungs should compensate for this acidosis. So it should increase the respiration rate to expel more CO2. If you saw that, you would have a low CO2, but it's in normal range here. If you remember those simple rules earlier for the compensation, is that partially compensated, everything would be abnormal. If it was fully compensated, the pH would be in normal range. Well, here we have a value that is still in normal range because it's not helping, and that is the CO2. The CO2 is within normal range, 35 to 45, so this is uncompensated. So the answer here would be metabolic acidosis, uncompensated. All right, last question, guys, to test your knowledge. A pH is 7.32, a CO2 of 48, an HCO3 of 27. All right, step number 1, acidosis or alkalosis. It's below that 7.35, so it is acidosis. Okay, step number 2, is it respiratory or metabolic? Okay, going through either step here using the Tic Tac Toe or the row method, you're going to find out that it is respiratory acidosis. Okay, so now step number 3, uncompensated, partially compensated, or fully compensated. Okay, we look here, pH is abnormal, CO2 is abnormal, HCO3 is abnormal. Everything is abnormal. What's that rule? It means that this is partially compensated. Okay, so respiratory acidosis, partially compensated. And to explain the pathophysiology behind this once again, we have a respiratory system that's causing the acidosis. So to compensate, what organ needs to compensate? The kidneys. The kidneys need to compensate by increasing the alkaline. What is alkaline? Bicarb. What controls the bicarb? The kidneys. So to hold on to that bicarb is counteracting that acidosis. So that is where it's saying it is partially compensated, working on being fully compensated eventually, because at least the organ is helping here. So everything is abnormal, it's partially compensated. All right, guys, I hope this video helped you understand ABG interpretation and the compensation. Once again, if you haven't already, download our ABG worksheet that's completely free on our website if you go to the link down below in the description. I'll see you guys in the next video. Hey guys, first of all, thank you so much for watching the video entirely through. It makes our day if we know that nursing school got a little bit easier after watching one of our videos. If you guys like this video, make sure you like it, subscribe to the channel for more, and drop down in the comments for any more ideas that you need help with nursing school. If you want to contact me personally, it's 940-218-4062. Thank you guys for watching. We'll see you in the next video.